Hi, I'm William, and this is my presentation for ENG104, and I'm doing it on nodal analysis. The key principles of nodal analysis are Kirchhoff's current law, Ohm's law, and then with those principles, you can get some equations. You're going to have to solve those equations simultaneously, or you can use matrix maths if you're confident with that. And just a little bonus thing is knowing how to convert power sources from voltage to current and vice versa, which isn't necessarily required, but can help a lot once it gets more complex. So we'll do an example because I think that's the best way to learn it. So if we see here, we're trying to get V1 and V2, and we just want to get an equation at each node. So node 1 is where it says V1 on that diagram, and we can see 4 amps are entering. And knowing Kirchhoff's current law, it has to equal what exits, which is I1 and I3. And same at I2, at node 2, I3 is entering, and I2 and that 2 amps is exiting, and they have to equal each other. Now, using Ohm's law, we can convert that so they're in values of V1 and V2. So we have the 4 amps staying there, and then I1 we can see is V1, which is the voltage drops V1 minus 0 because it's going from V1 to 0 over 2 ohms. Same, it's going from V1 to V2 on I3, so V1 minus V2 over 12 ohms. And that same principle is shown in the node 2 I3, which we already proved. And then I2 is V2 on 6, and then the 2 amps, the current exiting that node as well is denoted there. Now we want to use our first equation and just rearrange that. We'll get V2 as a value of V1, where 7 V1 minus 48. And then sub that into our second equation. This is just how you solve simultaneously if you're confident with that, like I said earlier. So V1 minus 7 V1 plus 48 on 12 equals 7 V1 minus 48 on 6 plus 2. Rearrange that, you get 720 equals 120 V1, which is V1 equals 6 volts. You want to plug that back in to your V2 value over there. V2 equals 7 V1, or 7 times 6 in this case, minus 48, and that gives you a value of V2 of minus 6 volts. And there you have both values that you wanted. And now, to best check your knowledge, I'd recommend doing this question. And you want to find the voltage drop across V3. Use the same principles as I just used then. And if you can get that, you know you've got it down. Yeah. Thank you.